Good evening. Hello, everyone. Welcome. My name is Terry Carey. I am an Assistant Director of Admissions for the Duffield College of Engineering. We are thrilled that you're here to join us tonight for a student panel where you will hear from both our staff and our Duffield Engineering students involved in our project teams program. So in just a moment, I am going to invite the panelists to join me, but first I wanted to give a quick overview of how the evening is going to unfold. We'll begin with some introductions from each of our panelists, including both of our staff and student representatives. Then each project team is going to give a brief overview of their work. And then after that, I will ask some of the wonderful questions that you all submitted for our students to answer. At the end of the session, I will share our contact information in case any of you have additional questions or would like to connect with our office. So without further ado, let's get started and welcome our panelists. They're going to pop up here in a moment. Thanks, everybody. So we are going to start off with some introductions. Charlotte, would you mind going first and telling us a little bit about yourself?
Sure, no problem. Thank you, Terry. My name is Charlotte. I am from Washington, D.C. originally. I'm majoring in mechanical engineering, graduating in 2028, so I'm an incoming junior. I'm part of Design Build Fly at Cornell. I'm going to be the incoming full team lead this year, and I've participated in Cornell project teams since the start of my sophomore year.
Wonderful. Thanks, Charlotte. Carol, would you like to go next?
Yeah, of course. Thank you, Terry. I'm super excited to be here as one of the panelists. And my name is Carol. I'm actually from Toronto, up in Canada, and I'm studying biomedical engineering. And my graduation year is 2027, so I'm a rising senior this year. I'm on debut, and currently I'm one of the co-team leads of my project team after being on the team for 5 semesters now.
Wonderful. Thanks, Carol. Next is Skylar.
Hello, I'm Skylar. I'm from Rockville, Maryland. My major is mechanical engineering. I graduated December 27. Project team is CU Sail, and I'm the full team lead. I've been on it since my freshman fall.
Wonderful. Thanks, Skylar. Lucas?
Hi, everyone. I'm Lucas. I'm one of the autonomy leads on Cornell Electric Vehicles. I'm from New York City. I'm a mechanical engineering major. I'm graduating next year, so coming up soon. And yeah, I've been in product team since I was a freshman. So
Thanks, Lucas. And Jabron.
Hey, I'm Jabron. I'm from New York City. I'm an electrical and computer engineering major, and I'm graduating in 2028. My project team is called Cornell University Unmanned Air Systems, or CUAir for short, and I'm the incoming electrical lead for this year. I've been on the team since my freshman fall.
Wonderful. Thanks. And finally, for our students, Davis.
Hi, thank you, Terry. My name is Davis. Sorry, I didn't correct you earlier.
Oh, I'm sorry,
Uh,
Davis.
no worries. My name is Davis. I'm from Boston. I'm a mechanical engineering graduating uh 2028, so still got 2 more years. I'm on Cornell Formula SAE, or otherwise known as FSAE. I'm the rising suspension lead, and I've been on this team since my freshman spring.
Wonderful. Thank you, Davis. And now I would love to introduce a staff member who works very closely with the project teams, and that is Kate.
Hi, everyone. Thanks for joining us this evening. My name is Kate Ryder, and I'm the Assistant Director of the Project Teams program. And I, along with 3 other full-time staff members, work very closely with our 36 teams and especially with our student leaders. And we provide training and oversight and advising support for the students in the program. And I'm going to start off before Terry leads into the questions for the student panelists, just by giving more of an overview of the Project Teams program, and specifically touching on some of the details of the program that often come up in questions. One of the things that makes Duffield Engineering Project Teams so unique among other colleges and universities is the fact that our teams are almost entirely student-led. So as I mentioned, we have a small staff team that manages the overall framework. and provides resources and training and oversight. But we don't directly manage any of our team operations. So the teams are entirely led by students who rise into leadership positions over the course of their time on the team. And they have a very high degree of autonomy in terms of the way that the teams are organized, their project planning timelines, how they spend their funds, and they also have a very high degree of accountability to the program. So it's a very high challenge, high support environment. We have a total of 36 teams, and they're doing all kinds of different engineering work, but we often say that they break down roughly into 4 categories of work. So many of our teams here tonight are doing design, build, compete type of cycles throughout the course of the year. So, they have a given project like a car or a plane or a sub, and they're working within given design parameters, creating their final product and bringing it to national or international competition and seeing how they do against other student teams. We also have several teams that are innovation focused, like Debut, who is represented tonight. And so these are teams that are given more of an open-ended type of challenge to solve, and then they have to come up with the very best solution and then present that again, often at a competition. We have several teams that are doing community-based global partnerships, so working around the world in small, often underserved communities to bring better resources or solve problems within, working with local partners on the ground. And then finally, we have a handful of completely digitally based teams who are doing app and web development. The other thing that's very unique about our program is that students do earn academic credit by being on a team. So we have a series of 3 courses that our students can move through over their time on the team. An onboarding course, and then sort of a core course through which they're gaining skills, and then ultimately a leadership type capstone course that's offered to students who have been on their team for at least 2 semesters and are doing, they're stepping into some sort of leadership role on the team, whether that be a named position or whether there may be more of a technical lead on the team. The other question that often comes up is, how do I get on a team? So you do have to apply to join a team. It is competitive, so I'm not going to sugarcoat that because I know that the word is often out there that it's highly competitive to get onto a team, but I do think there are some misconceptions as to why it is so competitive. We run a shared process to try to reduce that competition and stress on applicants as much as possible. So all of our teams are recruiting at the same time, and they have to offer slots to prospective new team members at the same time. Applicants complete a general application, and then they have to complete individual applications for every team that they're interested in applying to. And that can be, as many teams as someone is interested in. And then they continue on through a round or 2 of interviews with the teams that move them forward, and how those go depends on the team that a student is applying to. For the last few years, we've held steady at about a 30% acceptance rate across the program. And so this is where that competitive aspect comes in. The reason for that 30% rate is really because of supply and demand. It's not because of rigorous technical or previous experience standards that our teams have. Because our teams do offer academic credit, they can only grow to a size that still allows every single member of the team to have meaningful work throughout the course of the year that aligns with the number of credits that a student is registered for. And so that's, we have a high number of students that want to participate on teams, and we have a limited number of spots that are available. At the same time, almost 1,800 students a year participate in our program. So we are serving a lot of students within the college every year. And anecdotally, most students who would like to participate on a team at some point during their 4 years at Cornell are able to do that. And then finally, I'll touch really quickly on our spaces. We have two large build spaces, one that we call the Experiential Learning Lab, which is in the basement of Upson Hall. That's also where our staff offices are located, so we're very accessible to the students. And then we have another facility just off campus called the High Volt Lab that houses some of our teams that have very large projects, like a 26-foot concrete canoe that can't fit in the spaces on campus. We also have partnerships with labs and workspaces all over campus, from biomedical wet labs to pools for water testing. Some of our teams test in the Cornell Pond facilities. So almost anything and everything you could think of, we have spaces for students to do the work that they're trying to complete through the course of the year. So I think that covers some of the main highlights. And I am going to turn it over to the students now so you can hear directly from them.
Thank you so much, Kate. So the first student that we were going to hear from was Davis and talk about a little bit of an overview of the team that you belong to.
Thank you, Terry.
Yeah.
That was a great, wonderful introduction about project teams. So hi, my name is Davis. Again, to reiterate, I'm a representative of Formula SAE, also known as Car Team or Formula. So our team designs, builds, and races a Formula One style race car every year in the International Formula SAE competition that takes place in the Michigan Speedway. So one of the unique things is we are the oldest project team. We recently surpassed about 40 years, which, if you think about it, is when our parents went to college. So it's a long time ago. All in total, we have around 10 sub-teams, five of which we call powertrain, which are more electrical leaning, five of which are chassis, which are more mechanical leaning. And one of the great things about our team is having 10 sub-teams, you're able to get a lot of practical experience in many different engineering niches. So for example, if you want to design a PCB, you can do that. If you want to do battery engineering, work with cooling, thermal systems, coding or firmware, you can do that on the electrical side. But we also have aerodynamic structures and of course motorsports on the more mechanical side. So every team member on our team engages in a year-long design, build, and compete cycle. So you not only learn the basics of CAD, of finite element analysis, but you also learn how to build, manufacture, machine, put things together. And finally, you also get to validate, create testing, and of course, at the end, the best part is to compete. So I think also a great feature about our team is you also get to choose what you want to do. So I actually did not come in as an engineer, but I came in and internally transferred as an engineer later. And a lot of students on my team and a lot of other teams that will be spoken here today do actually find what you want to do. So a lot of mechanical engineers will actually transfer into electrical engineering because they find that really, really cool. So also on our team, you are exposed to a lot of different disciplines. So you do become a pretty well-rounded engineer from many different aspects. And also, I got to shout out our business team, which a lot of our team members are involved in. So you can get some good non-technical experience as well. And outside of engineering, I just got to say, our team members are really close with each other and we love to have fun. So that's FSA.
Fantastic. Thank you so much. All right. The next is CU Air. Jabron.
Yeah, hi everybody. Again, I'm Jabron. I'm gonna be talking a little bit about CU Air and what we do. So CUAir is a team that builds an autonomous VTOL aircraft from the ground up. And so what VTOL stands for is vertical takeoff and landing. You can actually see our aircraft from last year right here. And so if you'll notice, it has four propellers and four motors, like a drone, but you can't see in the back. There's also a propeller that pushes air horizontally. And you also notice the two wings here. So the idea is that it takes off like a drone. Then once we're in the air, we turn on that propeller in the back. Once we get enough airspeed to generate enough lift, we can turn off the four vertical motors and we're flying like a plane. And what's pretty cool about the team is that we developed the aircraft and it can fly autonomously. So we can take off autonomously, set waypoints to where we want the aircraft to go autonomously, and then land autonomously. Our competition is every year, and it has mission objectives such as image recognition, classification. So that uses a lot on the software side. That uses a lot of neural networks. And then on the mechanical side, uh, we design the plane and build it from the ground up. So all of this we made ourselves. We get the molds, and then we lay out the carbon fiber, and we do all the manufacturing in-house and the assembly. On the team, there's a lot of ways to get involved. There's mechanical sub teams, there's software sub teams, there's an electrical sub team, and there's a business sub team. So there's a lot you can do. As a freshman, you'll apply to one of those disciplines, you'll get placed on a sub team, and you'll be given a freshman project that'll let you really explore what that kind of discipline is about. You'll also be given smaller projects that give you a chance to touch other disciplines and maybe figure out if there's something else that you're more interested in. Like Davis mentioned, like maybe you'll do a smaller project. Maybe you join on mechanical and you do a smaller project on electrical and you find that more interesting. So you can switch over to the electrical sub team and design circuit boards with us and all that stuff, which is pretty cool. Something I'd like to emphasize is that you don't need to come into any of these teams, but especially CUAir with any experience as a freshman. We don't look for experience when we're evaluating applicants. I think that's really great because it gives us a lot of opportunity to meet a lot of freshmen who might not come in with experience but have great work ethics, great passion, and all of that. So I would say for sure apply to whatever teams you'd like and give it a shot, even if you don't have much experience. And yeah.
Fantastic. Thank you so much. All right, next is Lucas. Talk about your team.
Thanks, Terry. So yeah, I'm Lucas again. Just I'm on Cornell Electric Vehicles. We're one of the newer teams in the block. So we're founded, I think, 2014. So we've only about 10 years old. So we are, I'd say, one of the more interdisciplinary teams. So what we do, we make a electric car from scratch, from the ground up. We design the chassis, the drivetrain, steering, electric software, everything, and we send it to the Shell Eco Marathon, which is pretty cool. It's at the Indy 500 racetrack, and we get to race for efficiency. So it's not for time, but we see over a certain distance, can we have the least amount of energy expended for the same speed, and we compete to do the best in that. But more recently, what we've been doing and what I'm heading up, it's the autonomy initiative, is that we're transferring our car to be fully autonomous, and we're writing all the software in-house to do both data analysis and the autonomous algorithms in-house. And so like all the panels have said, I'd say one of the cool things about our team is like we also offer all this really cool interdisciplinary stuff. Just to say from my experience, I'm a mechie, and even though I'm doing all this autonomous driving stuff, I started out in like the most non-software thing possible of doing carbon fiber manufacturing, of making the chassis from scratch. We make some of the biggest parts in the school. It's pretty fun. We had one of the parts of the car was like the size of half a bathtub, just to get you a good image. So that was how I came into the team, was I'm still a mechie, but I still was in the like hardware side. But then as someone who always liked coding, gradually shifted and now I'm the autonomy lead, and I'm really liking that. So like everyone said, I think product teams really highlights that with engineering, you come in first year undecided, you don't have to make up your mind. And you're allowed to really choose where you're ebbing and flowing and not make up your mind. Obviously, you have to choose a sub team, apply to it, and show that you care, show that you have interest. But that's not the only thing. If as long as you do the work and you do it well, you can really do wherever you want to be, as long as you can actually perform and people like you. So aside from that, I'd say also what we're pretty cool is that we're integrating, especially with the rise of robotics these days, we're integrating a lot of new technologies, like if you've heard of reinforcement learning, of computer vision, of all these different models that are on the forefront of where robotics is going right now. We're integrating all this stuff, so which is pretty new, and I think we're one of the only people doing this, so it's really exciting. But yeah, that's what I'd say. Also, we do have a really large business on team who does a great job. And a lot of people who come into our team are not engineers. So you'll have a lot of people who are from business, from even like agriculture, for example, who just have an interest in electric cars. And like Gibran and Davis said, you don't really have to have all the experience coming in. As long as we see that, at least I would say, well, we'll talk about it more later, but that you have a really good passion and just can show that, hey, you have a cool way of thinking and you actually look at problems in a unique way. I wouldn't worry about it. So, yeah.
Fantastic. Thank you so much, Lucas. All right, Skylar is going to talk about CU Sail.
Hello, yeah, I'm from CU Sail, Cornell Autonomous Sailboats. We build, design, and manufacture the sailboat from start to finish every year. Um, that starts from the design phase in the fall, where we'll design the mechanical and electrical components. Additionally, for our competition, our sailboat sails autonomously, so the software part of the team will be doing the algorithm and the computer vision to do the search and rescue aspect of the competition and the endurance part. Um, the mechanical side, we pushed a lot of boundaries from going from a custom hull with resin infusion carbon fiber, which, if you don't know what it is, basically the resin gets sucked through the fibers and makes an even weight distribution throughout and makes it stronger. And we really just are looking for the most interested people when they're applying, not necessarily people coming in with the most experience, as everyone comes from different things. And we also, like all the other teams, have a lot of people at the end of freshman year say, well, I want to go ECE or I want to go MECE after they've learned more about the classes and gone through more, so they'll switch up. And it's really a great opportunity to learn these practical skills um, early on that you may not quite learn as quickly inside the lectures.
Thank you so much. All right, our next one is going to be Carol from Debut.
Yeah, thank you, Terry. So yeah, I'm here to represent Debut. We are one of the premier biomedical engineering teams on campus, and I think that what's really great about Debut is, again, you really get to be creative and create a product that has never existed before, but also in the process make a real impact in the medical community. I think that another thing about what makes Debut unique is that we model the entire medical device innovation process, which begins from identifying a unmet clinical need to designing, prototyping, testing, and finally like pitching a solution. So rather than working on isolated assignments, members also experience what it's like to build a almost like a biomedical startup or product from the ground up. And along the way, you'll learn about technical design, about clinical problem discovery. So for example, we like our phase one R&D members, they get to conduct stakeholder interviews to really learn about what is a lack in the medical community. So because we focus on innovating novel devices that have not been explored before, we would operate on a longer 2-year project cycle of ideation and validation. So during phase one, students will focus on exploring and speaking with stakeholders, like I said before, and developing a initial blueprint of their design. During phase two, the project moves into development and testing, where students would actually be able to test their device on let's say like patients who this project would be used on. And every year we select and submit 2 of our strongest projects to biomedical engineering competitions. And over the past few years, it's been really great, and our teams have performed very well and earning first place in Medtronic student competitions, as well as earning first place in BMES Venture debut competitions. And I think that for freshmen coming in, you really do not need to arrive with a lot of years of experience or technical abilities. You really just need to have a little bit of curiosity, initiative to start a project, and a willingness to learn. We have a very established new member education program that will guide you through the initial pitch, how to prepare a pitch presentation, how to how to learn to solder, and all of those things along the line.
Thank you so much, Kara. Appreciate it. All right, and our final representation here today is from Charlotte.
Hi everyone, I'm Charlotte again. I am part of Design Build Fly at Cornell, also known as DBF. So, as you might guess from the name, Design Build Fly kind of falls into the Design Build Compete category of team. So the goal of our team every year is to build a remote control plane for a competition, which happens at the end of the year, called the AIAA Design Build Fly competition. The competition happens in April every year. We get to compete against 100 other teams from across the country, which is super fun. This year, the competition is going to be in Arizona. Every year, the competition gives all the teams across the country a new challenge, which is really exciting. And that's a huge part of being part of the team is understanding the challenge and tackling it differently each year. We don't actually know what the rules are going to be this year yet. We'll find out in August. Last year, for example, our remote control plane was tasked with stowing a banner and deploying it mid-flight. So things like that we have to incorporate onto our plane beyond just the fact of building a plane that can fly and be stable in flight. So to tackle this challenge, we have 5 different sub-teams. We have about 40 members total. The cool thing about DBF is that it's actually very interdisciplinary. So we have a mechanical sub-team, which houses a lot of our mechanical engineers or people with similar interests. That sub-team tackles the fuselage of the plane as well as the systems, like, for example, the banner this past year. We also have our aerodynamics sub-team, which is for anyone interested in aircraft stability, wing design, plane sizing. That's a super fun one. But then we also have our propulsion sub-team, which tackles the propulsion of the plane. Our plane uses usually like a lithium polymer battery. So it's all an electrical system. So we look for a lot of electrical engineers or people with interest in that type of engineering. However, if you don't know yet what you want to do, that is also completely okay. And we would love to have you on our team because there are so many different types of projects you can explore. Usually how we do it is we just are going to admit you onto the team. And then once you join the team, you'll get a chance to explore the different sub-teams and figure out which one draws you in the most. We follow an iterative design, manufacturing, and testing process throughout the year is kind of how our team functions. So typically how it goes is we create our design, in CAD, we manufacture it, and then we test it. So we take it out to a field, we fly the plane, we see if anything breaks, hopefully nothing. Last year, we actually built and tested 4 different planes before we even got to our competition plane, which was super exciting. So you get a lot of exposure to building and testing, get to try out a lot of different designs, figure out what's going to work well, what's going to go wrong. The other thing I want to mention is the analysis side of our team. So when you're building an aircraft, it's super important to understand the physics that are interacting with the aircraft, which was actually something that really drew me to DBF. I was originally going to be a physics and computer science major before switching to mechanical engineering. So I was really interested in computer modeling and understanding how the physics would interact with the design. So that's also a big part of our team if anyone is interested in that. And then lastly, just to mention a few other things that I wanted to say, my favorite parts about DBF, we have a great team culture. Everyone is incredibly supportive of one another, just kind and cool people, really great people to meet at Cornell. We're a medium-sized team, which means that individuals on the team can really have a strong impact. So if you join the team and you have something you're excited about, projects you want to explore, and you put a lot of time and effort into that you are going to see the impact of that work on the team, which is really exciting. And we're all united by a shared love of planes and aerospace, which is pretty fun. We like to be nerdy together. So if you're interested in planes, you should definitely consider joining DBF. But that's it from me. Thank you, Terry.
Fantastic. Thank you, everyone. I always love hearing these overviews, and I'm always so impressed by everything you guys accomplish in a year. And you said you build 4 planes before you even get to the actual finished product. Everything you guys are doing is just incredible. And I love the fact that you are taking engineering and actually doing it, right? Like this is definitely something that is not necessarily in theory. You are applying it to a real project. You're bringing it into the world and you are actually developing it, creating it, and making it a real thing, which is just fantastic. So thank you all for that overview. I also love that you guys touched on the fact that project teams are open to any major. So you are going to be working with people who aren't necessarily engineers, which I think is a great reflection on what real engineering is like. When you are an engineer, you're going to be working with people outside of the field, and so I think that it's just a wonderful program all around, but it incorporates so much of what engineering really is after you graduate into this actual program. So thank you, everybody, for talking about your team and bringing us a little more information about that. So this next section, I'm going to talk about all of the wonderful questions that our students submitted. So the first question that I have, and a lot of you touched on this, and I appreciate you bringing that in as well, but one more time, just to bring it around, is how do first-year students typically find a project team that's a good fit, and what opportunities are available for beginners who have enthusiasm but maybe limited technical experience? Does anyone want to take that one? Davis, do you mind taking that one?
Yeah. Just trying to find the mute unmute
That's
button.
okay, you got it.
Yeah, so how do first year students find a project team that is a good fit? I'll definitely say if you have options, it's not easy to choose. A lot of these teams are really, really cool. And you will often find that multiple teams are a good fit for you. I would say definitely narrow down to the teams that you find interesting, like genuinely, passionately interesting, because a lot of students will spend 3 to 4 years on this team, which is basically their whole college experience. So you really want to find something that you really want to love. Like if you love cars, we have 4 different car teams that are available. You should definitely look into all of those. Um, I would definitely say take a look at what you can explore on that team. Don't bottle your neck to, I did PCB design in high school, so I know I want to do PCB design, right? If you're interested in the broader electrical or you want to explore some of the firmware or coding side, try to find a team that can support that. Some teams may have more firmware work to do than other teams, and that's maybe somewhere you can explore. Um, but again, you know, as we've all said in this panel, like experience is not necessary when you apply. It's more of the enthusiasm. I'm pretty sure every team that's on this panel has some sort of new member education, some sort of training. We have the machine shop downstairs that will teach you how to machine. We have all these team members who will teach you how to solder. On my team, I would say maybe 80% of our electrical team members did not know how to solder when they came here. So, I would say, definitely find that team that you're interested in and really take the time to think about it because again, this is almost your whole time at college.
Thanks so much, Davis. All right, our next question is approximately how many hours per week do students dedicate to these projects? And then a follow-up to that, how do you balance your studies with project teams?
Yeah, so I can take this one on. Thanks, Terry. So, yeah, I think it actually comes into one question at least in my experience. So, just a disclaimer, I do spend a lot of time because I really like what I do. So, let's see, in a week where there's 2 different weeks, I'd say. There's one week where you're doing it for the fun of the game. The other week where you just got something that's due like, in terms of like the product that you need to get done. Otherwise, you're just not gonna have time to get to it. So, I'd say either way, I'd probably spend like I don't know, 18 hours, if that can maybe something like that. But again, disclaimer, this is like pretty much just like what I like to do anyways. It's pretty much what I would do if I was bored. So I really wouldn't take it out. I would take that with a big grain of salt. Like if you just want to, like dip your toes, slowly get into the waters, like I'd say that's totally normal. But if you really love what you do, the hours rack up, you don't even notice it, I'd say. But I would say that the balancing the studies part actually can come out naturally, more naturally than you think. For example, for the Mechis, a lot of the stuff that you do on your product team is translates directly to your classes. So I'd say, for example, for a lot of the mechanical people, you have to say, oh, how do I design the system that won't break? How do I design this thing that I know will do a certain task? And that skill is something that usually comes straight into classes. So for example, statics, just for so Mechis out there, just knowing when something bends, breaks, twists, you already come into that class knowing how to do it. And same thing for the cars people, knowing how the car is going to turn the right way, that's another class. And the same goes for other classes as well. So if you do CS, like I'd say even more so for what I'm doing now as a mechie who's in robotics, as someone who's doing all this autonomous stuff, that's directly into my research and what I'm working on for a career anyways. So all this stuff I'm doing on my product team, it's pretty much what I would be doing anyways if I had access to different things. But what's amazing about product teams, and I think Terry's touched on this, is that we get all this access to these amazing resources and staff and people that can really help us out. And not only just help us out, just like, of course, with conversations, but also we just get the resources we need to go test on physical things and do physical real testing and, being able to transfer that from, something you see on a computer to something that actually drives around or goes in the water or flies. That's because we have this great program that supports us. And so I'd say that again, that it sounds like a lot like, oh, this guy can do 15, 20 hours a week on fronting. That's a lot. I don't see myself doing that. I'd say think again once you actually start doing it and really enjoy it, because a lot of people will also just, do homework for 5 minutes. They'll be in the lab, then they'll just do their project anyways because they're done with do their homework. But in any event, I'd say that for a lot of teams, the studying and the product teams actually fuse together a lot more naturally than you think. So.
Thanks, Lucas.
Yeah, I think I can add a little bit onto that. But yeah, I definitely agree with Lucas because I think sometimes when you're on debut, when you're working on this project that you're really, really passionate about, and on top of that, it's a project that you really thought of and created yourself, or like the blueprint was something that you created, you tend to spend a little bit more time onto it, even though it might seem daunting if you're not in the process of it. But I guess to put like a number on it, typically for R&D members, the workload might be around 10 hours around per week. And that would include like our meetings, sub-team work sessions, as well as independent project work sessions. And that said, it definitely ramps up as we get closer to major deadlines, like when we approach competition submissions in late spring. So I think during those times, you might just find yourself putting in like even more work hours to get the prototype and that really functional, like working prototype work ready. And I think that after you spend all those times working on it, and then you really see this device that, let's say, could like being used by patients with Parkinson's or like being used by patients that are in need of this device, that sense of accomplishment is really, I would say that is really worth all of the time that you spend working on the project. And as for balancing with classes and studies, I think it's really about time management and prioritization. I usually find that treating my project team hours like a scheduled class or like a lab session really helps me stay on track. And I mean, if you are a Google Calendar person like I am, I usually just have like a huge chunk of time blocked in my Google Calendar, maybe on like a Friday or like a Saturday night to work on this prototype. And then I think that sometimes it could be a good break from studying as well because you're applying what you're learning in lectures, all of those theories, into a tangible device, which can actually solidify and be fun in the process.
Thank you so much. All right, our next question is, what do students usually gain from being on a project team beyond these technical skills that they are learning?
I can take that, Terry. One of the greatest things you'll find with the project team is the great camaraderie that comes from it. Most teams, including ours, will do social things outside of the engineering quad or engineering in general, where we'll just hang out, we'll go to dinner, we'll um, go places together, do things that isn't directly engineering, and you'll also gain valuable experience on how to like operate essentially a small business or a research group because you're given a fixed budget and constraint to then you have to follow to. You can't just go buy whatever you want. You have to plan it out, think about it, and work together as a team. And you'll get really close with everyone on your team.
Thanks, Ken.
Yeah, and I can add as well. This question, I think, really just makes like it makes me think about like how much of an impact being on a project team has had on my life. Like the the things you will learn and the things you will gain are really huge and really will add like a massive dimension to your Cornell experience. Um, like Skylar said, there's the social aspect, the community, like you will be part of this community that shares a passion, that spends a lot of time doing the same thing all together, shared goal. Um, People who probably are in your classes as well, so you have support in your classes. People who might be looking at jobs that you want way down the line, 4 years down the line. Um, People you can talk to and network with. The other thing I wanted to mention beyond the community is project teams also really teach you like how to be an engineer. Um, so like you have your classes, right? And your classes are going to teach you all the technical skills that you need to be an engineer at the end of the day. That's what a Cornell engineering degree will do. You will learn how to CAD eventually. You will like learn how to do finite element analysis in your classes. Um, which are also things you learn on your project team. But your classes don't really teach you like all the other aspects of being an engineer. Um, One of those is like working on a team. That is like really a huge skill. And it's something that like makes you a better engineer and a better person, understanding how to do that and building confidence in relying on your team. Your team will be the ones teaching you and helping you, and also helping each other out. Like if you know how to do something, teaching others, that's a huge skill. And then it is also like really good, like professional exposure. Like a project team is like a small engineering business in a way. And so I think students that join project teams like really build a strong sense of what it means to be an engineer and develop these kinds of valuable skills that you don't get from your classes, along with, of course, huge community. I really like can't imagine my Cornell experience without being on a project team. So I would like definitely really encourage everyone to look into it.
Thanks so much. All right, our next question is, are project teams more focused on real world hands-on applied projects, which many of you have said yes, or is research also integrated?
Yeah, I can take this question. So I would definitely say there's both sides of this, but of course, all these projects are probably more hands-on applied. And you can kind of see this by just knowing what these teams are doing. So for example, if you're building an electric car like my team or Lucas's team on CEV, you're building an entire electric vehicle from everything from the chassis to the battery to the autonomy side, the vision. And these are direct things that are applicable to, let's say, Tesla, who is building electric vehicles. So when you take these skills in this project, you're actually able to apply it into the real world, um, like that. And another example would be we have a lot of aircraft teams on here, right? Aerospace is always going to be a big industry, and a lot of these skills will definitely be applicable. And I think another thing to highlight about this applied hands-on experience is all of our teams work year round, most of them, and you really get the full engineering cycle. Like Charlotte mentioned, like you really get to know what it is to be an engineer. You start from design, then you build, then you manufacture, then you test and validate. And these are all things that you can't do from a statics textbook, right? Some of these statics textbooks will give you equations, but there are lists of assumptions in order to use that equation. You're in the real world now. You don't have access to all those assumptions, right? So a lot of the times you do have to think out of the box. You do have to make approximations and you do have to test and you do have to break things to know how things work. And I think that's the great thing about project teams is they effectively fund you to go around, play around, and test the limits of engineering, right? We had our monocoque, which is our basically our frame of our car. One time that just completely broke, and that was maybe $10,000 or more down the drain. But we learned a lot from that, and we didn't make that mistake again. So it's definitely a lot of hands-on applied. Now, I will also say there is a lot of research aspect to this. For example, some of our autonomy work on my team and some of the other teams looks into actual self-driving autonomy research. So, for example, LiDAR or how to process images and the firmware behind that. Like a lot of this work is looking into actual research that people are doing, or even doing that research on your own. And then, of course, taking it back and applying it to the real world. So, I would definitely say you get a lot of hands-on applied experience, but we do have a lot of R&D sub-teams on across all different project teams where you can get more of that research focused side of the project teams. But all in all, super cool stuff.
Yeah, I'll just add on to that. Very similar ideas to Davis. The Cornell engineering project teams as a whole are very much focused on the applied side. Pretty much the goal of every team is ultimately to create a product, a physical product, go through the design, the testing, the manufacturing, and the product. And a lot of that is messy along the way. Manufacturing, errors that come up, you have to be prepared for that problem solving and that really like hands-on aspect of STEM. So that is, I would definitely agree with what Davis said regarding that. Um, but also at the same time, if you are a person who is very interested in research and the theoretical aspect, um, there is a big important place on the project teams for you, um, because of, as Davis said, like you there every project team is doing research and development at the end of the day because we're all trying to get better and we're trying to understand what designs we should be pursuing, um, based on what people have done in the past, based on what the research says. So, like I kind of mentioned earlier, Design Build Fly has our analysis sub team. A lot of teams have like something similar along those lines, research and development. For us, those team members are looking at what teams have done in the past, what's the optimal way to build a wing, should we add wingtip devices or not, what does the past research say? So research is important on a project team, but it exists to serve the goal of creating an engineering product, like designing a hands-on applied um, product at the end of the day. So that's what I would say about that.
Charlotte. All right, our next question is, what is the coolest thing that you were able to make in a project?
Yeah, I could take on this one. So you can see right here. So, so this is actually my freshman year project. I got very lucky because we were on starting to make a new car, and so I got to learn how to design a car from scratch. Like, at least not the whole insides of it. That's way too much for one person to do, but the outside of it. So this right here, I learned that there's a cool way to do it that all these auto manufacturers use, like Ferrari, Lamborghini, and all these like super cool car companies you've heard about. they all designed in this really cool program, and I got to learn it, and it was super cool. And I got to take on that myself, and that ended last year with having this as the final result. This is all full carbon fiber. I got to see it end to end, and that was amazing for me. And now I'm actually getting, now I'm able to make that same car I designed on the outside of autonomous. And so it's a really cool thing where, like people have said, you get to go from design to build to test. And I think that's super cool. And I guess I'd also say that the really cool thing about it is that I'm able to just merge all my interests together in a way I wouldn't even have thought I even could do before I got there. Like you don't really get to think about that. You don't really get to say, "Oh, I want to put this exact inch of mechanical, this exact bit of CS." It just happens, and I'd say, have faith that it'll all work out. So we'll talk about more of that later. But yeah.
Yeah, I can add on to that. So one of the coolest things that I've gotten to design is a two-axis gimbal. So I used a couple of motors to control the orientation of a camera. So when we're flying, or when this guy's flying, and is banking or making turns and it's not level, the gimbal stabilizes the camera, so we're always pointing straight at the ground or in the direction that we want to point the camera to take good images for our imaging pipeline. And that's a lot of fun, especially as a freshman project, because I got to integrate with a lot of different sub teams. So for the physical models, I had to talk to a lot of mechanical people. And then for the integration with the software and the imaging pipeline, I got to learn a lot about that. And so, like Lucas just mentioned, you do get like bits and parts of other bits and pieces of other disciplines, and you might not get to choose as much what it is, and it kind of just happens. It's always cool to expose yourself to new things that you're not familiar with. I'll say something really cool that the team is doing this year is that we are going to transition our propulsion system to tilt rotors. And so we're going to remove that horizontal propeller that I was talking about earlier. And instead, the front two motors are going to tilt down gradually. And that's a really cool project. No student team has done it successfully so far. We had a test flight last year where we got really close and something unfortunate happened, but we learned a lot from it. And I really think that this year we're going to be able to do it successfully. We were the first team to do a VTOL plane at our competition, and hopefully we'll be the first team to fly a tilt rotor plane next year at our competition as well. And it's a super exciting project. It's pretty challenging. There's a lot of dynamics that go into it, and it integrates with a lot of different disciplines. So that's something super exciting that we're doing this year. Yeah.
Thanks so much. Great. We are going to wrap it up a little bit here with one final question. And that is, if you could give one piece of advice to someone applying to a Duffield engineering project team, what would it be?
I can take that. Be open-minded. Don't say, oh, I only want to look at this one team if you don't exactly know what you want to do. Don't be afraid to go to the project fest or club fest and look around, see what the other teams are doing. Um, there are some teams that are very similar, like the car teams or the plane teams, and you might find that you en would enjoy one or the other more, and just be open-minded when you're applying.
Thanks, guys.
Yeah, I could add on from there. I'd say, I guess, two small things that into one big thing. One, just be passionate, be yourself. Like Skylar said, just show that you care. And I think a lot of people, that one thing that people miss sometimes is that people just don't even say, we ask them, oh, why are you interested in our team? People don't know. So just show interest. It's just show that you care, and it will go such a long way. Like I think David said earlier, just show that you're actually passionate about your team and the team that you're going to apply to. Just show that you're actually interested in it. If you're not interested in it, don't apply. I'd say quality over quantity. And I'd also say just as well that it's not about skill, like everyone's mentioned. It's more about, can you show that people are you actually going to put the work in when no one's looking? Are you going to do that small thing no one asked you to do? And I think it's more about showing that. And it's not about saying, oh, I did X and Y product and whatever. And like Skylar said, even though you have all these different teams around, I'd say that a lot of people on our team don't like cars. And that's just because it's just a system to work on. Like even for the autonomy stuff, a lot of people are doing robotics, and that's totally separate. But you get to do whatever you think that applies. And so don't think of like, oh, just because I did a car project in high school, I could do a car in school. Sometimes that does apply, yes, but I'd say just make sure you could show anybody that's going to read your application, besides that you're interested, just, hey, I actually took a product, I did it from start to finish, or I did something I found cool and I spent all night looking at it. that's the people we look for. It's not about, oh, I did this thing and I had 8 people do it with me. It's okay, did you actually find it interesting? Did you actually do it and actually understand what you were doing? So I'd say that's what it is. So
Thanks, Lucas.
I would say try to have fun with it as much as you can. A lot of people are probably going to be stressed because it is pretty competitive. But it's actually a really fun opportunity. Project Team Fest is super cool. That'll be, I believe, in early September, and all the project teams will be there showing off their projects, and it's super cool and just inspiring, honestly. So use the opportunity to get to know the teams, actually talk to the members on the teams, and get to know them, and understand the projects they're working on. As I think was touched on earlier, this team is going to be who you're with for 3 to 4 years potentially. So look for the one that feels like a good fit. You're excited about the project, you like the people, apply the teams that speak to you, and just have fun with it. It's going to be great, and it's a great way to get started at Cornell.
Yeah, adding on another piece of advice, building off of what Charlotte, Skylar, and Lucas mentioned, is you are going to be on this team for 3, 4 years, hopefully. The biggest piece of advice I would give you is to make sure you do a lot of research into the teams that you want to apply for, the teams that you're interested in. Not only will that help you stand out as an applicant, but it's also a good way for you to figure out what you're interested in. Something that Skylar said, I would like to emphasize too, like, yeah, go into this process open-minded. Do research for teams that you maybe are interested in, that you're not too sure about, want to learn more about. You can look at the websites, you can go through the social medias, figure out what recent projects people are doing. I think it's a great way to learn about the team, figure out what you're interested in as well, not just for a team, but also just in the general discipline of engineering. And then it also makes you stand out as an applicant as well. That, okay, like this applicant we think is genuinely interested, like they took the extra time to research this X, Y, and Z, and like this is why they're interested. So we can have trust that they're going to make sure that they contribute to this team and like add to the culture. And yeah, the one more thing I would say is like in terms of that research, you also want to research like is this a culture that you think you'd like to contribute to and fit in with? Like, is this something that's a place that's going to nurture you, that you're going to get to be able to learn a lot, that you'd want to contribute to in the future? Yeah.
Fantastic. Every time I do one of these panels, I'm always so impressed by our students. I just am so in awe of the things that you create, but also just like you're so poised and able to communicate so well. So thank you very much for being here. Kate, thank you so much as well for talking to us a little bit more about the program overall. And that concludes our event. Before we sign off, I do want to once again thank our amazing panelists for joining us and giving some insight into what it is like to participate in a project team here at Duffield Engineering. I also want to thank Robin. You didn't see her tonight, but she was in the background keeping our technology going. So thank you, Robin. And then finally, thank you all for joining us this evening. I hope you learned more about our program and had some of your questions answered. If you have more questions, we had a whole other list that we just didn't get through because of time. Please feel free to reach out to us. Our email is engr_admissions@cornell.edu. And then finally, I want to also plug our final virtual program for the summer. It's on Monday, August 10th. It's going to be a Q&A session with an admissions officer. So you can register for that online and submit your questions about the admissions process, our program, or any other questions you have. And Robin and I are going to sit down and ask them back and forth. So we'll be able to hopefully answer some of those questions about applying to college. So thank you, everyone. I hope you have a wonderful night.